Hi everyone, this is John Wen. In today's video, I'm going to go through the research updates since my past week. In the past week, I still working on the deep learning workflow in the data view. And from the past week, we noticed that the training performance is not so good as existing libraries such as Keras, TensorFlow, or PyTorch. So compared with our system, we don't have the momentum or rmsprop and atom that's available in our CUDA implementation right now. So we're thinking maybe this is a weakness we have right now because we cannot actively adapt to the learning rate and how the training can be more efficient, as well as can avoid to result it in local optimal. So I think that is a good way to move forward. So I spent some time in the past week to understand the mechanism behind the momentum, rmsprop, and atom. So right now I have much better understanding on each of them. And also I'm currently working on to design the data structure and also the layers objects and neural network objects in order to incorporate this kind of optimizers in our current CUDA implementation, because we need to find out a very easy way on the user side in order to choose different optimizers. I think we may need polymorphism for sure, because we're going to have the object-oriented objects in our CUDA implementation and trying to make different kind of constructor available to the user, despite whatever user are choosing. Maybe they choose a momentum or rmsprop and atom. So each one of them will be working at the end in our implementation. So that is the purpose of the design right now. So we're thinking about to have a better or the best or the most efficient way to deal with the data and also the objects, and trying to make the code as efficient as possible. So here's some screenshot I took from Angel and G's class. So I think that is very neat and very summarized what we are going to implement. And here is a momentum about the implementation of the momentum. So basically, there are 4 steps to implement the momentum. The first step is to compute the dw and db, which is a derivative on the weight and bias on the current mini batch. So that is what we have done right now. And so we can directly use what we have, the dw and db, for the first step. And for the second step, we're going to introduce a new variable that's called the vdw, that is a momentum of the dw. So this can be passed from iteration to iteration. So that means we are going to have a new field in the objects or in every layer that is called the momentum. Either the momentum for the dw or the momentum for the db. And we are going to calculate the current iteration's momentum based on the last iteration's momentum. And the calculation is like this. We're going to use a beta times the last iteration's momentum plus a 1 minus beta times the current derivative of the weight. So this is how we calculate the new updates of the momentum. And what we update inside the w is we're going to minus alpha, which is learning rate, times the vdw, that is momentum of this iteration. So you can think about the first term is a kind of weighted average in the past past iterations, because it's going to average the certain amount of the iterations that has been done before, and then we are going to add the current new iteration. We're going to add the current derivative, either the derivative of weight or the derivative of the bias. So that is how we update the weights in the momentum. And normally we're going to use beta equals 0.9. That is very commonly used. And also similarly, we are also have another optimizer that is called rmsprop, and this is stand for the root mean square propagation. So the root mean square is quite similar to momentum. So the first step is also we're going to calculate the dB and dW, and then we're going to introduce a little bit different but quite similar to the momentum. We're also going to calculate the SDW based on the last iteration of the SDW, and then we're going to have a dW square, and this is element-wise dW square, and we're going to times with 1 minus beta, which is quite similar to the momentum. And after all, when we update the weights, we're going to use a learning rate to times the dW over or divide by the square root of the SDW. So that's why we say we have root mean square. So we have the root square over here, and we also have a mean, which is the first item to have a weighted mean over the past iterations. So this is how we get rmsprop. And we also have the add-on. So add-on is basically a combination of the momentum and rmsprop. So you can think about we're going to calculate them together and add them together. So for the momentum, it's very similar. We are going to calculate by using the last iteration's momentum, either the VDW or VDB, and then we're going to have the SDW and SDB calculate from the past iteration. That's for the rmsprop, and then we're going to update them in this new equation, which is basically to minus the W or minus alpha, which is learning rate, times the VDW. We can also correct this by dividing by the 1 minus beta to the t times. So this is an equation how we can correct it or not. Sometimes people want to correct it, sometimes they don't want to do this. This is to help we eliminate the bias of the weighted bias. So that is how we can do the corrected value. And then we can divide by the square root of the SDW, which also can be the corrected, and plus a sigma. This sigma is to avoid sometimes these terms can be zero, and that can cause some error to the back propagation. So this is something very small we can use to avoid that kind of error. So this is some values we can adopt initially, or most of people do not train them. So they're just using the fixed size or fixed value for each one of them, like the alpha 1, which is for the momentum, alpha 2 is for the rmsprop, and a sigma will be 10 to the power of minus 8. So this is something they're going to use. So I'm still working on to design as well as to prepare the new coding on the current CUDA implementation, and hopefully I can move faster in later week, and then I will have something to present new in the next week. So thank you so much for your time, and hope you enjoyed this video, and until next time, happy coding.